I started my recording. We'll start the portal.azure.com to open the Azure Kubernetes Service. I've explained previously what is the Azure Kubernetes Service architecture, but let me reiterate it once again. We'll have a master and worker nodes. Worker nodes are the ones are just like when we started going into a scenario where we installed a Docker, and in that Docker we tried running containers. Similarly, worker nodes are the ones which will be running those work containers. So that time in the previous scenarios, we try to host Nginx. We try to run a Nginx hosting platform, which end of the day, which can host the website, and that is running on a container. That is a workload. Now, workloads are the ones, or the applications, or that front end, back end, or whatever you wanted, or the necessary dependent data tiers will be running on the AKS work on the worker nodes. And because we wanted persistent volumes and all that, we on databases, we prefer external services like PostgreSQL, Azure files, all these things, and disks to be interacting with uh, these worker nodes. Okay, so worker nodes are like similarly like machines, not similarly like machines, they are machines. They are virtual machines. But when you're creating Azure Kubernetes service, you're going to create a set of worker nodes. That is nothing but virtual. You're creating a virtual machine scale set, which is going to create virtual machine scale sets are nothing but a group of virtual machines of identical. They're identical VMs. That nothing but an identity. So whatever OS you have in one VM will be in the other VM. The same OS and same functionalities will be there. It's just creating a clone of VMs on my virtual machine. So that's nothing but a virtual machine scale set. Term it as. When you're creating an Azure Kubernetes service in Azure, you're going to create, end of the day in the backend, it's going to create a set of virtual machine scale, a group of virtual machines, identical virtual machines, and they are termed as virtual machine scale sets. So why identical virtual machines or or why virtual machine scale sets? Because when you wanted to increase worker nodes, you can increase by auto scaling in virtual machine scale sets and all that. Kubernetes was trying to utilize here when they developed Azure Kubernetes Service. They try to consume Azure virtual machine scale sets as their worker nodes for the Kubernetes architecture be set up. That whenever there are more number of requests, automatically based on the traffic congestion and all that, they will increase the worker nodes count. It has to be increased from 10 virtual machines worker nodes to 20 worker nodes, and the virtual machines scale sets will do it incrementally. That's that is about this worker nodes, and every worker node will have kubelet installed in it, which will end of the day interact with kube API server, the master node. And who is responsible to maintain the master node? Azure is the one who is responsible to maintain the master node, and that is nothing but the control plane operations and everything. The control plane management related to the Kubernetes worker nodes and everything will be handled by Azure, and we are not responsible to maintain that. And that's what Azure is saying that, and you know to pay for that. The thing is, you're going to pay because just because I wrote master, it will not be of huge size. It was meant that it is only does the job of managing and communicating with worker nodes and listen to the uh, kubelet and maintain the master node components in that machine. Okay. And what does master node have? It has Kube API server. It has scheduler, which will take care of scheduling pods in in those worker nodes. There is pods and there is nodes. Nodes are nothing but machines, virtual machines, and nothing but worker nodes, which will end of the day run pods in it. The pods are nothing but a group of containers. So you wanted a set of deployments to happen, a load balancer and a worker, an application front end, and all that. Pod is the one which will ensure that it is running on a node. that will have a group of containers to achieve some functionality end of the day. And we have scheduler, which will take care of those scheduling reports and the respective containers inside it. Next one we can actually talk about is etcd or it's etcd. Etcd we call etcd means etcd. When a machine is trying to communicate with other machines, worker nodes, they are going and communicating with the respective containers and all that. How is that happening? Because etcd is having the key value stores. What specific container, how do you have to access, what credentials you maintain, all the key value data will be securely stored in etcd in a key value pair. And then we have controllers. There are different types of controllers, replica controllers, pod controllers, node controllers, and all that are there. So this end of the day, which will send the, it will try to manage them, and if there is anything, it will send the request to through the Kube API to scheduler, and scheduler is the one which will take care of it to a Kube API server. The Kube API server, in a way, indirectly will directly communicates with the kubelet which are installed in each of the machines. What is kubectl? So this is nothing but just like in Docker, we see Docker client, we see kubectl, kubectl. Okay, let me spell it. Okay, kubectl, kubectl. We call it kubectl, whatever it is, whichever you prefer. I've seen people talking about kubectl or kubectl. Mostly I've seen kubectl. So this is the one which Azure takes. The networking component. So the way these worker nodes and the pods in with what type of network they're trying to communicate, all that we will talk about it right now while we are provisioning Azure Kubernetes. Any questions here? I'm assuming everything is good. So that's for the confirmation. So let me jump into the other one, which is Azure Kubernetes Service. Let me provision it. Here it is, Kubernetes Services is the one. Click on create a Kubernetes cluster. I'll choose VM-RG and I'm going to create sample one. So at this point of time, I can go for a cost optimized one. I'll show you the difference. And the ECS is a region, and the cluster name, I'll keep it as demo cube. Cake, whatever it is. And K8 is also a short form for Kubernetes. Call the short form for Kubernetes is K8. And then retry AKS free try, and here always prefer the latest one which is not in the preview state. It is recommended, but this is a default one, but which is not in the preview. We don't prefer a preview one in the production and all that, or testing and or whatever you're planning to. So you always prefer the latest one and enable with patching. I'm going to leave it as it is. So what is enable with patch? So whenever there is a latest one in Kubernetes and all that, you wanted that to be upgrade the determine which cluster will be upgraded based on the new AKS and Kubernetes releases. If you wanted an updated Kubernetes which is never released, you wanted to install it. If it is approved and not in preview, then you can go and enable with patch. So I'm going and I'm saying that it is okay. Here, I'm going to decrease the VM size. Here, it's saying what should be your node size. So I said, right, that we are going to create a set of virtual machines. Okay, worker nodes. And it's going to be a virtual machine scale set. So you are only going to, when you're creating a virtual machine scale set, you're going to tell what would be the size of VMs, because all the VMs which will be getting created in the virtual machine scale set will be only identical VMs. There will be no preference of choosing to increase one VM size and extra. You're going to uh, uh, choose what size of VMs you wanted to create the worker nodes whenever they're scaling and increasing and whatever it is. So here you're saying that the node count is 2 and the maximum is 2 count range. Do you wanted it to be auto scale? It will go for auto scale. What is auto scale here? Auto scale means you wanted to increase the size based on specific configuration. So if the CPU consumption is less, then we want the VMs to be going down. CPU increase is more, the CPU consumption is more. We wanted to increase the VM count to one more. That is what we actually try to understand from this auto scale. Manual means you're coming up with your own manual configuration to scale up or down. Here I'm right now choosing auto scale. So I'm going to node pool. So it's right now saying that I'm going to create two agent pools. One with two node count 2 and user pool. Just need a system agent pool because I don't want anything more than 2. So I'm removing that system count 2. Enable virtual nodes. I'm not preferring this encryption type. What is encryption address? How do you want the OS disk to be encrypted? So is it the platform managed encryption or is it customer managed encryption? What do you see if someone asks you about it? So if Azure is taking care of encryption, then it will become platform managed encryption. If it is you are the one who's taking care of encryption, then it's customer managed encryption. What is encryption? You are encrypting the data so that no one will get to know that the real exact data, what will be inside it, because you have encryption keys encrypted. If you are maintaining the encryption keys, that will become customer managed key. If by default Azure says that we will encrypt the data, we'll have the keys, encryption keys. You don't need to worry that even some engineer of ours who is working on those specifically on the track servers will not be having access to it because he will not have access to the encryption keys and all that. It's all secure. So here authorization local accounts with this one always prefer Azure AD authentication with Azure RBAC. At this point of time, I'm keeping local accounts and all that. What is Azure AD authentication with Azure RBAC? So it means that Azure AD is an Azure Active Directory which maintains the identities, the usernames and passwords, just like we have seen in Azure DevOps while we are adding users. We're connecting the Azure AD, Azure Active Directory. And from there, we are trying to access this. What are you seeing end of the day? You are you don't have what do you say? Um, what how do I keep this? You don't need to have the specifically which users to allow, users you should not be allowed. You don't need to maintain that. If you are using Azure Active Authentication, you don't have to worry about it a lot because this is a more secured manner. Because whoever is able to have access to the portal, and if you are giving those people only that Kubernetes so and so roles and all, that is called RBAC, role-based access control. RBAC is role-based access control. So role means based on role, you're going to give assign to control to the users. So if they're having a read access, then only they will only just have a read access. If they have write access, they will be having right. If they can assign permissions to anyone, they can be assigning. mission. So you assign those roles only, those functionalities can be achieved. That is how we are achieving least privilege principal access, zero trust policy. So your question can come around any way like this. When I wanted users, I have 10 users, so they wanted to access only couple of users should be accessing. What will be should be having access to Kubernetes? How should I achieve this process? You can say that through RBAC. So you enable Active Directory. That's the most better authentication method. It will help us in better authentication. And to the regarding the authorization, you use RBAC roles, your RBAC roles, and which will help us get a more better uh, granular least privilege access to the users whoever we wanted to access. So I'm going to hit this point of time, as this is a minimal thing, it can be expanded this point of time. So jumping into the next one is, do you wanted it to be Azure CNI network or Kubernetes? I would prefer Azure CNI network here, and so it will be created in a VNet VM, and I prefer Azure here, the network policies, the integrations. Let me show the integrations too. So here the Azure Container Registry. If you are not choosing, I believe, if you're going for dev test, I believe you want, okay, nice, that's been good. So we can pick, we usually for AKS, we will pick images from Azure Container Registry. Just like Docker Hub Registry, we are going to place our own images in our own registry, which we can create from Azure Container Registry. Azure Container Registry, the service where it can store images and all that, and you can choose that I wanted to pick image from Azure Container Registry. What if Azure Container Registry is not being linked? Nothing. It's going to go into Docker Hub and going to look for it. Here, I'm going to choose as none. I don't need to enable container logs, container insights. If you wanted to connect Prometheus inside it, uh, sorry for that. You can actually connect Prometheus metrics also, because Prometheus is one of the best methods in terms of monitoring your Kubernetes environment. And we are not getting into those things at this point of time. And the next one is infrastructure resource groups also. Whenever you're creating this Azure Kubernetes service, along with this, so you would be seeing what if you go into that service, Azure Kubernetes service, just like a VM is created, you go into that VM virtual machines and you'll see the virtual machine. Just like that, you will see in Kubernetes services, just like Kubernetes cluster. Behind the scenes, a lot of infrastructure is getting deployed. And where do you want that infrastructure to be deployed, also to be created? You're going to, anyways, in Kubernetes cluster, you're going to access Kubernetes cluster. The exact infrastructure which you are creating behind the scenes, in which resource group you wanted to place it, is what right now Azure is asking for. And thus, CSI driver, if you Kubernetes is going to create a lot of workloads, and these workloads might have to need, suppose it is accessing external services like PostgreSQL and all that, might need some sensitive data to be available to access it. At that point of time, you use this CNI driver where you store the secret in that PSI driver, sorry, not CNI, PSI driver, so that you use that as a secret store, and Kubernetes will consume those secrets which are there according to what you have mentioned in the manifest files. Uh, Let me go ahead and create right now. If you guys might be might be a bit confused in this some of the topics, it's fine. You keep going on because Kubernetes is a very huge subject as such. It just takes some couple of classes to even talk about it. Just because I wanted to actually integrate Azure Kubernetes Service into our platform, what we call into a release pipeline. Do it. That's the reason why I was doing. Oh, here there's an issue. Uh, just nothing but region quota. Okay. Region, you will be only given 10 cores as minus free trial. Pay as you go. If yours is a free trial, you will be only given 4 cores. Okay, per region. So if you are creating two machines of 2 core each, that means 4 cores is been done. If you are creating 4 core machines of 2, that means 4 core into 2 is like 8 cores. So uh, you have to understand this one, guys. So just keeping and giving you this understanding because whenever you're trying to create machines, you will face this region quota issue. So Kubernetes cluster to get created, it's going to take some 5-10 minutes. Meanwhile, I'll go to Google and I'll search for any demo on this Azure Kubernetes Service. Your questions here, guys, for explanation. I'm going directly into the Microsoft Learn documentation. Here we are trying to create a cluster. So that is happening through Azure CLI. So what Azure CLI is trying to say, this is a command to create. Just like the way you are going and clicking buttons in web page, you can send commands to create anything in Azure. And Azure CLI is one methodology to communicate in that way. There is PowerShell too. In Azure CLI, what is it saying? AZ is Azure. KS means aka Azure Kubernetes Service. Create, you're saying to create new the resource group, so and so resource group. You're asking to create this AKS. You're saying name. Name is of the cluster. AKS cluster is AKS cluster. And how many worker nodes you want? You need 2 worker nodes. By default, it's going to take specific size automatically because you haven't specifically mentioned here what size of it should be. And then you saying generate SSH keys that these nodes when they're communicating, they could be communicating with that. Attach ACR. So you're saying it should we pull the images from which ACR? ACR is nothing but Azure Container Registry. And once you're done here, you're going to first install Azure AKS CLI. Install CLI. Why do we have to do this? Because if you wanted to uh, run kubectl commands, first you need to install AKS related CLI. That's why you type AZ Azure AKS install hyphen CLI and get the credentials of the first. If you wanted to get any information about what is happening in the Kubernetes cluster, you need to first connect to the Kubernetes cluster. To connect to the Kubernetes cluster, you need to have just like the way you're connecting into virtual machine using username and password, the same way connect into Kubernetes, get the relevant information through cuttle commands like kubectl get nodes or kubectl. They'll ask you questions like when I wanted to run kubectl get nodes, I created a AKS. and I wanted to run kubectl get nodes to get the information of the nodes which are running in the cluster. What is the first command which I have to run? First command which you have to run is to get the credentials of the Kubernetes cluster. That is the command, common command is aged aks get hyphen credentials. So, and then you give the resource group, in which resource group the Kubernetes cluster is there, and what is the cluster name. That will get the credentials, and then you can run kubectl commands. To install kubectl inside my new local machine, what is the command for that? Az install hyphen CLI. It will install the necessary prerequisite in command line required for to interact with AKS. Any questions here? I hope you guys are understanding. Okay, so let's do that right now. So if you are not able to install AZCLI and all that, so I'm going the easiest method. I don't want to run the commands in my cloud shell, in my shell and all that, because sometimes those commandlets you will not be in a position to run it. So you can choose to run commands using Cloud Shell. So Cloud Shell is also a service which is provided by Azure. You can run commands, the Azure CLI commands or PowerShell commands in the online itself. That the first thing which you have to create is a storage account. It is asking that I don't have a storage account where I can run things on it. So I will go ahead and create it. Would you like to create? So I just clicked on create button. So it's going and creating it. Once the storage account is created for storing the commands, so the history of commands should be stored somewhere and all that. So, so it created one. Click on new session here. So I clicked on new session here. Open a new tab. I'm going to close this and the Kubernetes cluster to get the login. So let's just take some time. In Cloud Shell, I'm expecting that I know to install kubectl because by default it will be installed there. So you, yeah, kubectl is already installed. If I try to run that commands in my shell, it be might I not have installed in it. So then you will not see those commands. Yeah. So if you wanted that, you're going to run the command azaks install CLI. Yeah. So your Kubernetes services is not deployed. Going to Kubernetes services, we see demo k8. So this one is installed, and this is normal way Azure shows about a service. All things are being created and all that. So how many workloads are running inside this Kubernetes? How many namespaces are running in this Kubernetes? So I'll talk about in detail. I can talk only to a limited one. We'll talk about few things, primary things which we have to address while we are creating Azure Kubernetes Service. Most importantly, what is the node pool? Creating one node pool here. Okay, the master node, and then the agents terms of how do I keep it? That the actual workloads are going to run. So if I look even at the workloads, they would be running at here. We will get to know which agent pool, which node it is running. Just there are lot to explore when you learn Azure Kubernetes Service. That's the reason why it's a huge one. We have to even to talk about the service. Might go for a 2 weeks classes or at least 10, 14 classes. Uh, the infrastructure which I just explained, when we said that the infrastructure will be created in a different resource group, I go and see this is the one where the infrastructure got created. Now, this is the infrastructure related to Kubernetes. Please remember that we have a load balancer which will take the request and send it to the worker nodes and all that, which will listen to the Kubernetes, uh, send it to Kubernetes and cluster. And then we have virtual machine scale sets. One for one is for specifically for agent pool, one is for the users, and here we have a managed identity which got created so that it can interact with any of the external services securely. We have a public IP address. The okay, this is code. This is the architecture. Sorry, these are the infrastructure which is needed for the Kubernetes cluster to run. Please, we should not delete those. We should be aware that which resource group is the one which is maintaining the Kubernetes cluster infrastructure. You can create your own resource group and ensure that those resource group resources are not being deleted. Because when you choose all resources and even one check uh, Kubernetes cluster and you delete this one, this will become problematic because those are all some services are dependent on this. You will be unchecking resource group, which resources we don't need, and Kubernetes cluster, and you can delete the rest of the things which you don't want. This is how. So we also see that there are alerts which have been created. If you see here, alert got created for memory working. So CPU percentage, because we set up a auto scale. We created auto scale here. What do you say? Kubernetes a cluster to auto scale and all that. Because if you don't want you don't have a monitoring in place, how does it auto scale? When you clicked on auto scale and all that in terms of scaling, they created an alert which will keep monitor on CPU percentage and memory based on the memory. So if it is higher consumption, then it will increase the node count. If it is lower consumption, then they will decrease the node count. So I wanted to log into this. So I use this command zaks cli. So I'll clear the screen. If you run commands in bash, az commands will run it in bash. Here I will say my cluster got created in pm-rc, and name of this is demo 8. So that will get, so these credentials will be installed in the, please remember that it will be installed in .cube.config, .cube config. And once you right now run kubectl, so when you're running this command, kubectl get nodes, it is trying to communicate to the cluster which is being stored, that information which is stored in this config. So that's the reason why this, when you got the credentials, it's storing that context in config. So that kubectl, when it's getting and asking for nodes which are there, it's going to pull the data from the config and contact that specific cluster. Here it is, that specific cluster has three nodes. One is with a user pool and two in agent pool. Pool is nothing but a set of machines. One pool, agent pool, which is named as agent pool, it has two VMs. Other pool, we have user pool, which we have only one VM. If I wanted to get in space, there are some namespaces which are running. By default, these are the namespaces got created. Uh, kubectl, like I get I can get some things and all namespaces. Okay. Mm-mm. It's been long, so want to run an application in this. It needs ACR to be also linked to it, otherwise we can't run it. I can't take this demo. I'll take another demo. Created a cluster which is not. I'm hoping that it is not creating any ACR here. Okay, good. Not creating any ACR. And these are the manifest files. So here, let's copy this. Yeah, can create a name. I'll say paste this. I will go for outside, which now I say that hello YAML. I have this. I clear the screen, and now I'm going to deploy this. How do you deploy this? So these are the manifest files. So you deploy using kubectl apply. NF is the file name. You say hello YAML. And that's what they also explained it. And your install is going and setting up this one. So if you say kubectl get resource. Now if you see hello AKS is one of the things which is running there, and so that is services. So if you see deployment, there is three nodes, three pods are running. Okay, and it's running three and in different pods, and three are up to date and three are available, up and running for the last 32 seconds. So this is the external IP. copy this, paste it here. There you go. This is actually running on Kubernetes, guys. Okay. This is how what just happened. So Kubernetes administrators are the one who write this manifest files. Just explain what initially we are creating one service. Am I saying we are creating the service? Here, if you say kind, one is service, the other one is deployment. So when I was actually looking for get deployment, get services, I was looking for that. And if you see here, service with hello AKS is created, a deployment with hello AKS is created. That's what you can see it here. One is deployment, one is service. In deployment, you're seeing whatever respective things have been there. In service, you're also seeing what are things are there. Service, if you see, the name is hello-AKS. That's why you can see hello-AKS. And uh, what do you say? Type is a load balancer. That's why you see the type is a load balancer here. That's a service. And your target port is 80, and the container port from that is 80. So your so it listens from the it's sending a request here. It's an HTTPS request. At the end of the day, listening to the load balancer, and that is going to send it to the app to AKS. So here, if you see, the deployment is an app API version app, and name is hello-AKS, and it has three replicas. That means three containers sets. And here you're saying that's why if you go here, it's saying like it's running in three pods, and there don't get confused that with this hello AKS. They named this one the load balancer with hello AKS, and similarly the deployment also they named it hello AKS. Is it the right way to do it? Yeah, usually they prefer organizations do the same way because they meant to say that the workload and the load balancer were the same naming convention. And they named here hyphen AKS, and the container which is running here, the image was taken from Boxboard, which is nothing but from the Docker container, Docker hub registry, and there we have hello Boxboard, and that is nothing but this URL which you're seeing the web page and all that. And that's it. So that is what you can see, and here you see. First, it tried to create a cluster. You created AZAKS, then you asked to install CLA, then kubectl commands. Then you got the AKS cluster credentials. Then you tried to do kube apply so that the application is got deployed. So this is it, guys. This is how. So we are going to create a .NET application, and the .NET application we are going to make it as a Docker image. We are going to store it in Azure Kubernetes, Azure Container Registry, and we are going to write a manifest file which is going to deploy that application in the Kubernetes service. That's what we are going to do that in the next coming classes, and I am going to do that using pipelines. So using build pipelines, I'll build the application, make it as a Docker image, and using release pipelines, I'll deploy that image back into the Azure Kubernetes service. I hope it's clear. If you have any questions, kindly let me know, or we are done for today.